We're back for another online AC lab. So today what we'll do is we'll start in the classroom like we have in the past. And I've got some components to show you, talk a little bit about the evaporator and about the condenser. I have demonstration. You'll get to see exactly why we use vacuum on an air conditioning system and what it does for us. Then we'll move out into the shop, and in the shop, as you know, last time we were working on finding a leak in a GMC pickup, and we had gotten to the point where we knew there was a leak. We couldn't locate it, so we had put some dye in the system and a little bit of a refrigerant charge, and we saw the system was working, you know, when it had refrigerant in it, but of course we know it's just going to leak back out again. So we need to find that leak, and once we do find the leak, we're going to want to remove the remaining refrigerant from the vehicle so that it doesn't continue leaking into the atmosphere. We're not supposed to leave refrigerant in a vehicle that has a leak. So we'll start in the classroom, we'll start on the bench, and then we'll move out into the shop. I have an interesting little experiment here we can do. If you remember in the last video, before we could charge the system we had to evacuate it. So what does evacuate mean? It means we're putting it under a vacuum. And the idea is not just to suck out any remaining refrigerant. The idea of putting the system under a vacuum is when you put water in low pressure, under a vacuum, it'll boil at room temperature. So I have a setup here that I can demonstrate that with. Notice we're not going to be adding any heat at all. So let me just get that set up, and we'll be back. Here I have a vacuum pump that's very similar to what you find inside an AC service station. This is a little bit older one, it's got the wrong kind of fittings on it, but it's an electric motor and a pump. Here I have a glass jar just filled with a little bit of water sitting at the bottom. There's some color in it to make it a little easier to see, but it's just, and you can see it's not hot. I have no problem holding on to this. So what I'm going to do is I'm going to attach it to our vacuum pump. And I'm holding it in my hand, so it's not going to get hot. But let me turn the pump on. And we'll just give it a minute. In a very short time, you can see this is boiling. It is not hot. It is still room temperature. If this is 60 degrees, I'll be surprised. But because it's placed under a vacuum, that lowers the boiling point down to room temperature, and it's definitely boiling. So here I just want to show you what seals up these systems. You know, I have a typical refrigeration line here. This one here has a high pressure cutout switch on it. This would be the high side line, the smaller line. And here is most likely where it bolts onto the compressor or onto the evaporator. Here at the other end, notice we have O-rings. So let me just pop that off so we can get a better look at that. So just a little rubber ring, and it's important that you use rings that are compatible with the refrigerant and the refrigerant oil that's in the system, which is typically, you know, nowadays going to be R134A. Here at the Vehicle Training Center we have an assortment of these, but a lot of times when you buy a part, you know, they give you an entire O-ring kit, which is an assortment of different sizes. You know, when you buy a compressor or an evaporator, or you can just buy the O-ring kit itself, and it comes with, normally nowadays they're green, and they're compatible with the refrigerant and refrigerant oil that we're using. Here I have a somewhat smaller evaporator, and this one I'm guessing was probably replaced due to corrosion. It's all green. and so it was probably leaking. But the other problem it has, I'm not sure how well the camera can pick this up, but the fins on this in sections of it are completely blocked with dirt, dust, all kinds of, looks like little pieces of plants and things like that. So the trouble with that is it restricts the airflow over the fins. So the fin's job is to collect heat from the air inside the vehicle as it flows over these fins and transfer it into the tubes and therefore into the refrigerant, so it can be carried away from the evaporator out to the condenser where it'll be dumped off to the outside air. So if the air can't contact the fins, the efficiency of this system is going to be drastically reduced. Now this one, it looks like just the one corner is a little blocked up. I'm sure this would have still worked, but the more contamination there is in these fins, the less efficient this evaporator becomes. And if they become completely blocked, then it won't work at all. Another thing that can cause blockage when humid air flows over the relatively cold surface of this evaporator, you can have condensation on the outside of it. And if the evaporator is running too cold, so if the control system, the thermostatic expansion valve, or the cycling switch aren't working correctly, if this is allowed to get too cold, then that condensation that forms on the outside of this might actually turn to ice. If that happens, the ice will block these fins and air won't be able to flow through it, and then the evaporator will stop working. So usually the symptom of that is the AC system works perfectly when it's first started up. That's because there hasn't been time for any condensation to form and freeze. But after a period of time, and it depends on the outside temperature, it depends on, just how much too cold this evaporator is, but over some period of time, ice begins to form on the outside. So this has nothing to do with moisture in the system. This is just the moisture that's in the air, which there's nothing you can do about that. But the issue is the evaporator gets too cold, that moisture freezes and blocks these fins with ice. If these fins become blocked with ice, air can't flow through them. If air can't flow through them, then that air in the passenger compartment cannot transfer its heat into these fins and consequently into the refrigerant, where it can be carried away and dumped off at the condenser. Here I have a condenser. Again, I'm not sure what this is out of because this is something that was just in the classroom, but this one, the tube and fin design is a little bit more obvious. You can clearly see the tubes here that the refrigerant flows through. And so this is outside of the vehicle. The job of this condenser is to take relatively high temperature refrigerant that's flowing through these tubes and let that heat transfer into these fins and then into the air that's flowing over this condenser. And so the air is flowing over the condenser just because the vehicle's moving, or if not, because of the cooling fan. Most of the time, when you turn the air conditioning on, the cooling fans come on automatically to increase the airflow, through these fins of the condenser. Also, through the radiator too. So what can go wrong with these? You probably notice some of these fins are bent. Looks like, a little mishandling. Every once in a while, stones kick up. This is in a pretty vulnerable position. I wouldn't say that this amount of damage here is really going to have too much of an effect on the system. Obviously, it has a small effect because it is restricting the airflow through some of these fins. But unless the heat load is really excessive, there's probably enough surface area here to handle our cooling needs, pretty much all the time. So what you could be looking for, is any sign of damage on any of these tubes. If a stone comes up and puts a hole in one of these tubes, you're going to have a leak. If you see any signs of oil, or if there's been dye put in the system, and remember I said, the newer vehicles, a lot of them come with dye from the factory, so if there is a leak, it's immediately apparent. But you'd be looking for signs of oil or looking for signs of dye on the fins. And if you remember, I think I told you the last lab, refrigerant is heavier than air, so if this condenser were sitting in the vehicle like so, the most obvious place to find oil would be at the bottom. So it might run down and accumulate towards the bottom here. So what if our refrigerant system is working? We have the correct pressures in the system. The compressor is obviously working. It's charged. And we have the right difference between the low and high side, telling me whatever our metering device, whether it be a thermostatic expansion valve or a fixed orifice with a cycling clutch, if we determine all of those are working, yet we're still not blowing cold air into the vehicle, another place we can look is the inside controls. So what do I mean by that? If you look here, you can see there's a couple of fittings where the refrigerant lines hook up. So the evaporator core is inside this box here. And here on the side of the box are a couple of electric motors. Now I'm not sure, this one says it's the passenger zone, this one says it's the driver zone. So this is one of those dual zone climate controls like I showed you last week, where you can change the passenger and driver temperature independently. Okay? So I talked about this in other classes. You have an electric motor and you have a built-in potentiometer that can measure the position. And so the job of this motor is to control blend doors inside this evaporator case. And what the blend doors do is they determine which way the air flows. So if the blend door is in the wrong position, you're going to have air flowing through the heater core. And if air flows through the heater core, it's not going to come out into the passenger compartment as cold as it should be. So sometimes we find that the refrigeration system is working absolutely perfectly, but there's some sort of a problem with the air doors that are routing the air. And there are other doors that control whether it goes to the floor, panel, defrost outlets. But these ones here are the two different zones, driver and passenger, that control the actual temperature on an electronic automatic temperature control system. If one of these motors fails, what will happen is the potentiometer, which is feeding information back to the HVAC system, the HVAC system will see that potentiometer is not moving or is not in the right position that was called for, and so you'll get some sort of a diagnostic trouble code. Sometimes, though, the motors don't fail completely, but what happens is internally, the linkage that the door is attached, or that the motor is attached to rather, wears out, gears strip. There's just little plastic gears here. I don't know how clearly you can see it. And so the motor appears to be working fine. The position sensors on the motor itself. So the motor moves to the position it's supposed to, but the door itself has a bad mechanical linkage to the motor, and so it's still not in the right position. That's a little bit more difficult to diagnose. You won't necessarily have a trouble code from that. It may require actually disassembling things and taking a look. So I have another electronically controlled air door. And so here you can see the motor. The motor's electrical connection here. Not sure how clear that is on the camera. And then, there's some linkage that attaches it to this actual door. And I'm sure this is not good for the motor, but I can, force the door open like that. So what this motor is doing is actually moving some sort of a door inside the air ducting, behind the dash. So it's been known to happen. Maybe the lever arm could break off the door. The doors themselves, this has rubber seals on it to make sure that no air gets around it when it's closed. Those can go bad. All kinds of basic mechanical stuff, even if the motor's working fine. I've mentioned twice now how humidity or moisture can cause problems with refrigeration systems. So if you remember, before we charged, we evacuated. That was in the last video. And I think I showed you that live in the shop too. The other thing I showed you in here was the water boiling at room temperature. So that's the purpose of evacuating the system, get any moisture out. What happens if you don't get the moisture out? Well, you can have ice inside the system causing blockage in some of those small passages. Thermostatic expansion valve can ice up, fixed orifice can ice up, and then your flow of refrigerant is restricted. You might see the high side pressure go way up because it can't flow through that restriction, and the low side pressure go way down because you're starving that side of it. The compressor, suction side of the compressor is trying to pull refrigerant through, and there's a blockage. So we go way low on the low side, way high on the high side. That's a definite indication of some sort of restriction in the system. It could be caused by contamination, but it also could be caused by ice. The other place ice I showed you could be a problem is if atmospheric moisture on a humid day condenses on the outside of the evaporator. If that happens, it can actually block the airflow through the evaporator, and then even though the refrigeration system is working fine, the warm air inside the car is not actually coming in contact with the evaporator because the evaporator is encased in ice. So that's two things, two ways that you can have a problem with moisture in an air conditioning system. Now there's always going to be humidity in the outside air, so we can't do anything about that. We can control the moisture inside the system. We do that by making sure we evacuate. There's also a desiccant bag, so that's one of those things you see in packages that says silica gel do not eat. That's a desiccant. It absorbs moisture. So when the system is built, in either the suction accumulator or in the receiver, they put a desiccant bag. So it's called a receiver dryer or an accumulator dryer. So that's how we control moisture inside the system. Building in that desiccant and using vacuum whenever we have the system open to get rid of, boil off any moisture that has gotten in from the air. How do we control moisture on the evaporator? We really can't. All we can do is keep it from freezing. So if the controls are working right, if the clutch is cycling at the right pressures, that will keep the evaporator from getting too cold. If the thermostatic expansion valve is operating right on a TXV system, that'll keep the evaporator from getting too cold. As long as the evaporator stays above freezing, we won't have that icing problem on the fins on it. So even though it would be nice to keep the evaporator at 20 degrees so you could really blow colder air into the passenger compartment, we can't do it because of humidity, because of that icing potential. So that's why we have to have some sort of control on the temperature of the evaporator. Here we are back with our ultraviolet light, and I'm looking over the system like we did the other day when I first put the dye in and before I put the dye in. Looking where the thermostatic expansion valve is mounted on the firewall, I see a little bit on the service port. That's not unusual. That's where the dye went in. Here's my high side line, low side line. And I'm really not seeing any evidence of leakage here. So when I move back to the condenser, this is where I noticed something. Let's see if we can see this. Right here, where the receiver dryer attaches to the condenser, there's clear evidence of leakage right there. You can see a little bit running down the side of the receiver dryer. but right where the two come together, that appears to be where there's a leak. I've reconnected the ECR 2000, our air conditioning service station, to this vehicle that we were doing the leak check on. And let me open up the valves here, turning them clockwise. We'll turn and look and see what our pressures are now. Because this vehicle has a leak, it wouldn't be correct to leave the charge in it and let the rest of it leak out. So what we're going to do, we'll look at what the pressures are so we can see what it lost, but then we're going to reclaim the system so that we're not putting the rest of that refrigerant into the atmosphere. Since we know we have a leak in the system, we don't want to leave the rest of the refrigerant in here because it'll just leak out into the atmosphere, and that's not something we want to do. So what I'm going to do is recover the remaining refrigerant in here until the vehicle can be repaired. First thing it wants us to do is remove the hoses from the vehicle and recover the hoses. So let me do that. All right, I shut the service valves, which is the same as removing the hoses from the vehicle. So right now it's not actually removing any refrigerant from the vehicle, it's just clearing the hoses out. You can watch our pressure gauge over here dropping. That's just the pressure in the hoses, not the pressure inside the AC system. Same thing over here, 15, 13, 10, high side, same thing, dropping rapidly. So this takes a few minutes, pull the refrigerant out of the hoses so that then when we recover what's in the vehicle, we get an accurate reading. So let that run a minute. Notice we're into a vacuum, it's inches of mercury instead of PSI now. All right, next operation we're going to select is recover. So I need to go hook the hoses back up, open the service ports. Watch the gauges as I do that. When we hook into the system in the vehicle, they should go up and read the static pressure in the vehicle again. So now we're hooked to the vehicle and we're going to select recover. I know my oil tank is sitting at maybe 1/4 of an ounce, if that. So we have our service hoses connected. We check the oil drain bottle. We will press start. Remember, I demoed for you the refrigerant identifier on the bench or on a vehicle in the shop back when we were doing live labs. This one has a built-in refrigerant identifier, so we don't need to use that separate one. if the refrigerant in this vehicle is not compatible with the refrigerant in the service station, or if there are any flammables in there, anything that we don't want to pull into our equipment, it will not recover the refrigerant. So it's only going to pop up for a second. We'll see what the percentages are. Keep an eye on the screen. So 99.9% R134A. So we can watch gauges coming down. We can watch our digital readouts coming down. As we start actually taking refrigerant out of the vehicle, you'll see this is a scale inside the machine here that's measuring by weight how much refrigerant we're recovering from the vehicle. If you remember, there was 0.6 kilograms, which is about 1.32 pounds. That's what we charged the vehicle with during the last lab. We'll see what we actually get out. We know there's been some leakage because our pressures are lower, and because we actually saw the spot where there is some leakage. When this is complete, we'll check our oil drain bottle too. Normally, if we add dye to a system, we don't send it out for weeks on end. You know, we want to get it back in pretty quickly to see how much, or to see where the leak is, because as long as the vehicle is out there, refrigerant is escaping into the atmosphere, and that's something we want to minimize. So we're just putting the dye in long enough to identify the leak, and now we're removing the refrigerant so it doesn't continue to leak into the atmosphere. This was in a little bit longer because our access to the lab is really limited right now. So last lab I added that dye. Now it's been more than a week. So it's leaked out more than I would like to have allowed. So it says it's recovered about a little bit more than a half a pound. So this has lost about 7/8 tenths of a pound. Let's see. Yeah, it's still going up. Remember, we had 1.3. And we're starting to push on near half of it still in there, which is good. So 0.72. I'm actually going to restart recovery, and the reason I'm going to do that is we can usually get a little bit more out if we do this more than once. we're not going to do it 20 times. There's only so many hours in the day, but let me hit restart. And when we're all done, we'll check that oil bottle. If you look here, you can see there's still just the slightest amount of pressure in the system. On the gauge here, you can see just a little bit above zero, maybe 4 or 5 pounds. So if we do it again, we may get some more out. Right now we're at 0.72. Okay, we got a little bit more out that time. You can see, you know, we're into a little bit of a vacuum here. Look on the gauge there, we're a little bit below zero. So if I were going to immediately recharge this, our next step, of course, would be to press F3 to evacuate the system. I am not going to recharge this because we know it has a leak. And so there's a couple of reasons why we don't want to vacuum this. One, we're going to open the system anyhow. So after we do that and we replace a part, we always need to evacuate it. And the second thing is, if you're pulling air in, you know, air has humidity in it, so you're pulling moisture into the system. Let me just shut this off because it's a little noisy. So, because we have limited access to the shop this semester, we probably will not have the opportunity to repair this and recharge it. So that may have to wait, we'll see. We only have the 1 day a week, just Thursdays that I can be in here and for limited hours. So the job is a 6-hour job, and that does not include recharging it, but we know that only takes a few minutes, but still 6 hours, we'll see. I don't think that's really going to happen though.